Oh yeah, perfect. All right, so I'll go back to the main slide. So yeah, if you don't know, myself and Auke still work a lot with the OCPP library for Python. And we're presenting, obviously, how we go about maintaining this library, how it came about, and some of the things that we've found on the way as like personal experiences, I guess, and professional experiences, and how obviously we deal with having something open source and how to obviously move forward with that and keep it alive. So, Yep, so a little bit about myself. My name's Jared Newell. I'm a software developer at TMH, which is the mobility house. We'll explain a little bit more about that in a second. And at the moment, I'm working on a CSMS, and it's particularly for a CPO solution. For some of you who might be interested, it's focused on vehicle to grid, which is quite obviously, we're really at the cutting edge of the OCPP protocol, and we're really pushing the limits at the moment. I've also worked with charging station firmware in a similar solution to the previous presenter, and dealing with a centralized implementation of the controller and then having multiple EVSEs then attached to this single controller. And also contribute to the OCA as an active member and participate in the development of the protocol and try to obviously give feedback, but we'll get into that shortly. So a little bit about the mobility house. Obviously the name's not always very expressive, so I'll go into a little bit details what it is that we do as a company. In the main part, it's dealing or trading with energy and vehicle aggregation at the moment, but we also do microgrid management, energy management. So for buildings, there's a limitation of vehicles, having too many vehicles and not enough energy in the building, and then obviously being able to distribute that power within the building and making sure that, well, technically fuses don't blow and the building stays active. So this is quite interesting topic in itself. We support, as you can see here, 18,000 chargers sold and 1,500 fleets under management. So with that, meaning fleets, we also deal with buses and larger, not just your cars, but obviously buses and commercial vehicles as well. One other part to that as well is frequency containment as well. So we have stationary storage. With the stationary storage, we don't just do frequency containment. So if you don't know what frequency containment is, the grid expects this nice wave happening all the time. What you don't realize in the background is sometimes that wave gets a little bit funny, and if you apply electricity or take electricity out of the grid, you can then get this nice curve happening again. So that's basically what frequency containment is. And energy storage. So we have the stationary storage, which is big battery systems, for example, in the Amsterdam arena, and that then obviously collects energy, and then you can distribute it when, for example, there's a football match on at the arena. Those batteries can come in and then supply the extra energy required for that particular use case. I hand it over to Auke then.
Yep, thank you. So yes, my name is Auke. I work currently at Switch. Joined them 6 months ago. But before that, I was a colleague of Jared and worked at the Mobility House. And at the Mobility House, I was involved in the start of the OCPP project that is the topic of today. I joined this industry, the e-mobility industry, 5.5 years ago. Experience with dozens of chargers and cars. Worked a lot with OCPP 1.6, but also 2.01 and even 2.1, the future version already. And at Switch, we have two products. I work on an operating system for chargers. That operating system is agnostic of implements OCPP 2.01, ISO 15118, and plug and charge. Do a lot of Rust, like the previous speaker mentioned. We also have another product, the CSMS, that supports OCPP 1.6, 201, plug-in charts as well, and it also integrates with several roaming platforms like Hubject. Before we continue, I want to clear up some terminology. A lot of its terminology already is mentioned today, but for those that maybe watch this stream isolated online at a later point in time, I want to repeat maybe a little bit of the terminology. So what we did at the Mobility House back then was releasing a library in Python that speaks OCPP. So first, Python is the programming language that we developed that library in. It is, well, you might be familiar with other languages. We already heard a few today, Rust earlier. Maeve is developed in Go. Python is just another language in this ecosystem. It's a reusable piece of software that you can use in your code to so it allows sending and receiving OCPP messages. It's open source, and I will come in a minute about why we actually open sourced it back then. And well, it speaks up with the OCPP 1.6. It started with 1.6, but now also supports 201, and it has even experimental support for 2.1. That is the upcoming OCPP version. I'm not sure when the draft will be released, but I expect soon. Oh yeah, maybe what I didn't tell is all the development of this project happens in the open as well on GitHub. There the code is hosted and people can file issues and ask questions. The project started in 2019. It emerged from an internal code base at the Mobility House. And back then I was working on a smart charging product that distributed load among chargers, and one of the key components of that product is that it was independent from a specific charger vendor. So that was very important for the feature and for the product. But when I joined them in 2018, there was support for 3 chargers that each supported a different protocol, and that obviously doesn't scale. So the Mobility House back then wanted to, for the Mobility House, for that product was important that there would be one protocol to use to control different types of chargers, and that is why management decided back then, well, let's open source our implementation. Maybe that can help the ecosystem to converge to a single standard back in the day. There were, as I said, multiple implementations, different chargers had different protocols. So we released it under MIT license, that is a very permissive license. Do whatever you want, more or less. You can include it in your commercial products, proprietary products. You can fork it, mutate it, that's all fine. The library, as I said already, supports all versions since 1.6, the JSON one, not SOAP. It also supports the security extensions from 1.6. These extensions contain some improvements to the protocol that have been incorporated natively in 201, but have been backported into 1.6. The project allows you to, as I said, to send and receive OCPP messages, also validate those before sending or receiving so that you're sure they are valid. And I think it's one of the most popular OCPP projects on GitHub. If you measure it by the stars, it has, there are now a lot more, but back in 2018 to 19, when we created the project, Steve was there, already mentioned a few times, but that is only doing the CSMS side of things. This library allows you to use it both send messages in the role of a CSMS, but also send messages from the role as a charger. And I want to give a few examples. I just had a chat with Matthias from Micro OCPP. He just told me that he also used this project. They're developing charger firmware as well, and he used it to validate their ISEC-conform implementation. And that's one use case of how the library can be used. There is also another project called Home Assistant, also open source for home automation, that allows you to automate your lights in your home and your heat pump and whatever. And it also has support for OCPP, and that's based on the library that we created. And test automation, I just already mentioned it. Test automation is one example of how you can use it. And Jared will continue with some other examples.
So probably I've already discussed some of these points, but I'll breeze over them again. So as a charge point operator, obviously as a CSMS, for a particular vehicle aggregation platform, so that's the concept of having these movable batteries around in your car and be able to make use of the energy that those batteries can hold. And obviously with this particular platform, we're using OCPP. We're focused a lot on 2.1 because of the V2X capabilities with OCPP 2.1. The idea around the vehicle aggregation platform is, you might have heard of this term called flexibility. So the idea around flexibility is that a car remains plugged in for a long period of time, and that period of time you can make then use of the battery. So the idea is to have to be able to commercialize that flexibility in the battery. I think it's popped. Okay. Oh yeah, so this is, go back to that diagram, it's probably quite good. So this gives a nice pretty diagram of what this particular part of this product does. So you have obviously OCPP, which is the focus of this talk, and this library, which is used to obviously not just, well, OCPP is not used for trading the electricity, but obviously we purchase the electricity and trade it, and that then has to match to the number of vehicles that are available to absorb that energy, or vice versa, to sell that energy back to the market. So there is the value sits all the way between purchasing the energy to obviously storing the energy, and then vice versa. So second, I think if you go back a couple, it's one more maybe. Yeah, perfect. I think I already talked about charge point firmware, and I think this a lot of people have discussed also around the topic of using this OCPP library for a charge point firmware as an example. And I think we tried to focus in on that the library itself is designed as building blocks. So it's not as a complete solution that you download and you put in your charge point or you make a CSMS. The building logic side of this library is left to the individual, to the company, to the business model. And we provide all of the building blocks. So I guess we go into that a little bit later. And the last thing here is energy load management. So microgrids are being able to manage the amount of energy that's available to the building, and then how much of that energy we can actually use with the other items that are in the building. So we take into account side loads, and then manage, make the most efficient connection to the grid for the individual, for the business, for the company. In addition to that is integration of PV as well. So that sort of brings the whole building management, energy management under the one system. Yeah. So we're into the open source bit. So I guess we've had a few discussions today around why to open source. So some of these points might be repetitive, but we're certainly giving our experience, first-hand knowledge, myself and Auke, of what we've found in open sourcing software. I guess a lot of value that you can get is through consensus of the specification. So we know OCPP has the standard and the release the schemas, but there is often, not often, but there is times where there's discrepancies on understanding what one particular aspect of the standard is saying. And it's possible that in the field, the application is a little bit different to how the standard is described. So I guess by having the software available to everyone, you get then this feedback saying, okay, well, your library does this, or it's supposed to do this, but the standard says, well, it's supposed to do this or to that. So what we end up doing is working through making a bit of a decision on how to best handle each use case. So some of them are very straightforward. We can answer relatively quickly because we know that, okay, it's quite clear in the standard, this is how it's supposed to be implemented. But other times we end up having a little bit of a conference around how we are going to solve or how we're going to handle a particular problem. And I guess by having open source, we are focusing on one particular language, which is Python. We found Python very easy for people to use, to roll out as quickly as possible, to get proof of concepts together. And then for data analytics, a lot of people also like using Python. So as a CSMS, maybe you want to have some other business system attached on there, and obviously Python allows for integration quite quickly, quite easily. And once again, the feedback that we get is real-world implementation. So we're not just making up this stuff. We get feedback, and then obviously we can make adjustments to our implementation to make it somewhat more generic, but also adding features to this generic design as well, but not making it, trying to keep it, avoid having it specific in any way. Yeah, and I think I said, if we find discrepancies, we actually raise it with the OCA. We ask questions there to get the final point of truth. And obviously, this allows for the standardization. So if everybody's using the same library, they've all got the same differences in the application of the OCPP standard. So this makes things also quite easy as well. So to introduce new ideas and features, so obviously once it's open, then other people can look at our implementation and say, hey, look, I think you can do this better. And they might submit a piece of code and say, hey, what do you think about this? And then we can go through and consider, does it fit into the idea of the library, which is purely building blocks as generic as possible. Sometimes we can say, okay, this might be something good for a major release, and then obviously we need to then put in multiple pieces together to decide, okay, we're going to do a major release in the future. We want to sort of select all of the breaking changes, all of these ideas. How can we put them all together where it's, fits into the ideas of the library? Once again, yeah, improve on existing approaches taken, and also gives development direction, which is interesting. So if you're working for a business, or you might get direction from the company, from investors, or whatever the case might be. Obviously, when it's open source, where does your direction come from? Like, why do you do one thing over another? How do you set priorities? And that's pretty interesting. Pretty interesting way to look at coding as well is because you don't have particular direction, you have to define it yourself somewhat, but it's very loose as well. It's not a set of rules that, okay, I'm going to develop in this particular pattern. Yeah, you have to be fairly open to the direction of the library. Ideally, it comes with, once again, with quality. If people are going to like your library, if the quality's there, if you're responding to questions, people will email, people ask questions, all sorts of questions, and we also need to then prioritize how that fits into the idea of the library. And I've already talked about, I guess, we try to exclude business logic. I think I've covered most of those parts there as well. I guess it's a discussion as well, which is interesting. So if you have a library within a business, you can push through changes as quickly as you want, depending on how the business wants to drive a particular feature. But with open source, you're dealing with people that might be more ad hoc in their time schedule. They might not dedicate time to this particular project all the time. So there's questions that are answered, and the turnaround time can be quite delayed. So I think this is always something to take into account as well. So you're working in a different environment with people of, sort of not a common group, but you try to form these communities, I guess, with discussion, and hopefully people come back and want to contribute as well. So we just talk about maintenance. Maybe I should go through this a bit quicker. So I think this has already been spoken about. There's schemas, which are definition that you can abstract into different programming languages. Some of it's provided with the schemas, but in the standard, there's some parts that are not. So, or you have to interpret other parts as well. This is where the OCPP documentation comes in. So first up, we look at the schemas. They're considered as the truth. And then we move to looking at the documentation. And once again, corrections may be debated, and then we obviously raise those findings to the OCA. And we consider if we need extension to the library and how to conform mostly to OCPP. So I guess we have obviously just your normal maintenance, right? So if we find particular dependencies which need to be upgraded or that are no longer maintained, we might need to replace dependencies within the library as well. And from a security aspect, we need to try to keep as current as possible. So we might want to introduce a feature that's not available for a particular version of Python, but we found somebody with a different library and that's well supported. But over time, that library may no longer be worked on because it might be integrated into a newer version of Python. So this gives an example of the dependencies and maintaining the dependencies in the code as well. Okay, so experiences in maintaining an open source library. Once again, generic as possible. I think I've already spoken about that. Some approaches taken at the start, as with any software development, is very hard to sometimes change. We might find that we really want to work with a idea that somebody has, but we don't have a very good roadmap to integrate that without breaking a whole lot of stuff. So we have the problem with that probably any software developer has, is trying to ensure that we don't break something, but try to also integrate better approaches. So far, we haven't hit any roadblocks, but we've managed to work through the problems and compatibility, or how we want to move forward. And once again, there's major releases that allow you to do breakers, as long as we communicate that to people. Once again, I think I've already spoken that communication is best effort between the community or the people that are working on the library. And once again, OCP specifications open for interpretation. And I guess, once again, I just want to iterate that it's not just simply software development. We do consider impact assessment. So you have to consider, if we do something, how is it going to affect other people? So it's not usually a case taken, but certainly with open source, you're not working with a certain group of people. You want to really be a little bit aware of the changes that you're making and how much of an impact they can be. So we ideally want to keep people happy, although there's no guidelines for that. But I mean, people are not going to come back if your code's broken all the time and you're doing random things to it. And then it's just a trade-off between bugs, enhancement, and the time. So not everybody has dedicated time to develop on the library. So we obviously work with bugs first and then consider enhancements later on. All right, and that brings us to the end.